So this is a bit of a sad day. The last lesson of the year. The last lesson of grade 12. In fact, it might be the last lesson of math you ever take. Hopefully not. Hopefully it's not. Alright, so the binomial theorem. So yesterday we talked about, or the last lesson we talked about, Pascal's triangle. Pascal's triangle is interesting in itself, but it also has an application, and it has to do with binomial theorem. What is binomial theorem? Well, you already know what a binomial is. It's a plus b. Anytime you have two terms that are added in a bracket like that, that's a binomial. And you could do this. A plus b to the power 0, you know that's 1. You also know that a plus b to the power of 1 is a plus b. A plus b to the power of 2, this you spent most of grade 10 doing, right? You would FOIL that, so that would be a plus b times a plus b, and you would multiply and you would get this. So those are all ones that we have done in the past. In fact, you've probably done a plus b cubed, right? That would be a plus b 3 times like this, and you would have to multiply that out, and we could get this after simplifying. It's when you start going a little higher, power 4, power 5, how about power of 23? It starts to become really tedious work to have to multiply all that. And so we want to look at a shortcut. Okay? The first thing you should notice is take a look at the coefficients in this expansion of the binomial. Here you have a coefficient of 1, coefficient of 1, 1, 2, 1, 1, 3, 3, 1. Does this look familiar? Well, it should. It's Pascal's triangle. It's exactly Pascal's triangle. Okay? So you could even use Pascal's triangle and you know that the next coefficients would be 1, 6, 15, 20, 15, 6, 1, etc. Okay, so that's the first thing we should notice. But you already noticed that Pascal's triangle is also just combinations. Okay, so looking up here, this is row 1. It's our first entry in combination. And what did we do to find it? You would go 0, choose 0. In row 2, you would go 1, choose 1, and 1 choose 0 and 1 choose 1. Okay? So notice that each time that what the power is, okay, that's what you're going to use when you're doing your combination. So what do you think you would use when you have a plus b to the power of 6? Well, this is 1, 2, 3, 4, 5, 6. It's the 7th row, but you don't even need to know that. You would go 0, choose 6 for the first one. 0, choose 1. Sorry, 6, choose 1. 6, choose 2, etc. Okay? So that's kind of useful. We can figure out the coefficients. Now let's look at the variables. What do you notice about the power of a here? Well, it's decreasing each time. In fact, right here you would actually have a to the power 0. Okay, what do you notice about the power of b? Well, here you have power of 0, and then 1, 2, 3. They're increasing. The powers of a are decreasing. The power of b are increasing. There's one more thing. What do you notice about if you add the exponents up in each case? Do you notice how when you add them up, they always equal what the power is? Okay, so there's a lot of stuff going on here, and it looks maybe a little confusing, but let's just kind of refresh our memory or try to be a little more concise with those things. First of all, the coefficients are the numbers of Pascal's triangle. When the exponent is n, there will be n plus 1 term. So for example, if it was to the power of 15, there would be 16 terms. Okay? The first term, a to the n, and then the exponent of the power decreases by 1, down to a to the power 0. The opposite with b, it would start at 0 and go all the way up to n. And the sum of the exponents is n. Okay? So that's kind of the rules. Let's try one here now. Now, you know what? I look at this. I've never used that. But very quickly, let me just summarize. If you have any binomial to any power n, Notice you're going to use n in the combination, so n choose 0, n choose 1, n choose 2. You're going to start with x being the high power, n, and y being the power of 0, and this one will go up 1, this one will go down 1, and this one will go up 1. That's all this big, long, crazy thing means. It's nothing that you really need to know. Okay, so let's try this. The first 4 terms. How many terms would there be, by the way, in this binomial expansion? If it's a power of 8, there would be 9 terms. We're supposed to just find the first 4. Okay, the coefficients, you would go 8, choose 0, 8, choose 1, 8, choose 2, 8, choose 3, and so on. All right. Then we're going to look at x. You would start with x to the power 8, x to the power 7, x to the power 6, x to the power 5. And then y, you would start with y to the power 0, y to the power 1, y to the power 2, y to the power 3. Okay, notice the powers of x are decreasing, powers of y are increasing. The coefficients are just combinations using 8 as your first number. Okay, so that's expanding. Now we're supposed to simplify. Okay, and so you're going to go 8, choose 0. I know that's 1. X to the 8. Y to the power of 0 is just 1. I don't have to write that. Plus, what's 8, choose 1? That's 8. X to the 7. Y to the 1. And then what's 8, choose 2? That's 28. And then 8, choose 3. Is 56. Okay, now it just asks for the first 4 terms, but this actually would keep going. All right, it's that simple. Let's try another one. It says expand and then simplify. This time we have to do all of the terms. How many terms will there be? Well, there'll be 5 terms. Okay, you would go 4, choose 0, 4, choose 1, 4, choose 2, 4, choose 3, 4, choose 4. Okay, now this is a little bit trickier. We don't just have a variable here. You actually have a number and a variable. So let's put that in brackets. This is 3b to the power of 4. And then 3b to the power of 3. 3b to the power of 2. 3b to the power of 1. 3b to the power of 0. And similarly, you don't have a 1, you have a negative 1. All right, this is how we're going to get some negative terms in there. You should do a quick visual check to make sure that everything seems to be right here. You know, we're going 4, choose 0, 4, choose 1. The powers add up to 4 in each case, so it looks good. Okay, now let's simplify. Well, 4, choose 0, that's 1. Now here's the tricky part. What is 3b to the power of 4? This is 81b to the power of 4, and negative 1 to the power of 0 is 1. So what you have here is 1 times 81b fourth times 1, which is 81b to the fourth. Okay, let's try the next one. 4, choose 1 is 4. 3b cubed is 27b cubed. And negative 1 to the power 1 is negative 1. So now when I multiply this, I'm going to end up with a negative term. Okay, and this is 108b cubed. Then let's go plus. 4, choose 2, 6. 9b squared, 1. So this is 54b squared plus 4 choose 3, 6 times 3b times negative 1. This is negative 18b. And last, 4 choose 4 is 1. 3b to the power 0 is 1. Negative 1 to the power 4 is 1. There it is, expanded. Okay, pause the video, see if you can expand this next one. Alright, now that you've tried it, you're going to have 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. You get 2c to the 4 cubed, 2c to the 4 squared, 2c to the 4 power of 1, 2c to the 4 to the power 0. And then you have negative 1 to the power 0, negative 1 to the power 1, negative 1 to the power 2, negative 1 to the power 3. Simplifying, we're going to get 8c12 minus, okay, I'm kind of looking ahead a little bit there, so I'm going to get 12c to the 8 plus 3 choose 2, that's 3, and so that's going to be 6c to 4, and then 1 times negative 1 would be negative 1. Okay? Guaranteed there is always a question like this on the exam, where it asks you to expand. Okay, now we're going to just throw a little bit of a twist in there, because sometimes it doesn't ask you just to expand, it asks you for specific things about the expansion. Okay, and so we talk about the general term. So just going back here for a second, if I said, what's the third term? I would want you just to be able to find this. This would be the third term. Okay, and when it asks for the third term, it usually doesn't want you to simplify everything. It just wants you to be able to find that third term. Okay, a couple things I want you to notice about the third term. What's the power here? The third term, the power there is 2, and we're choosing 2 out of the 3. Okay, it's always one less. That is what we call the key number. Okay, the key number is one less than the term number. So if you're looking for the kth term, whatever that might be, then the key number would be k minus 1. Okay, so for example, look at this one. It says determine the 9th term. The 9th term, so what's the key number? The key number will be one less. So the key number is 8. So now when I think of doing this, instead of expanding the whole thing, I am going to look for the 9th term only. And the 9th term will be 10, choose what? Key number is 8. I'm going to have x to the power of something, and I'm going to have negative 2 to the power of something. Now I want you to notice this. The key number is 8. So the key number goes here, and the key number goes there. So what goes here? Well, we have a power of 10. These two have to add up to 10. And that's it. That's the 9th term. Now we can just simplify this. So 10, choose 8. So I get 45 x squared, and 2 to the power 8 is 256. So I can multiply that by 45. So I get 11,520 x squared. Okay. Similarly, if I want the 6th term, what is the key number? Key number is 5. So if I want the 6th term, Okay, I'm going to do 15, choose something. I'm going to do m to the power of something. I'm going to do 2y to the power of something. Okay, key number is 5. So 5 goes here, 5 goes here. What goes there then? 10. Okay, and it's that simple. You just have to know those little rules and it becomes pretty easy to do. So I get 3003 m to the 10 times 32y, oops, y to the 5th. And so this is like so. Okay, same thing, determine the 5th term. So here the key number is 4. And I think we're going to stop there. Okay, I'll give you some homework. You might not be able to do all of it yet. So it's page 744, numbers 3 to 11 and 17. Make sure you do the multiple choice as well. And I'll do the second part of this lesson as a separate video. There's also some review stuff you should be doing. I believe there's a few posted. Let's quickly check to see what, I think it's called exam questions. Now some of them are on perms and coms, but I love this page. This page has like every good question that I've ever seen. Okay, and there are some really difficult ones. Okay, really difficult ones. For example, number, let's see, where is it? Yeah, number 14. Okay, number 14 is really hard. Maybe we'll do that as part of the lesson tomorrow. Okay, so we'll stop there.